Good morning all. My name is Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. My subject is Computer Architecture. Today I am discussing about Computer Arithmetic in addition and subtraction. So, what is Computer Arithmetic and how is it related to addition and subtraction? Arithmetic instructions in digital computers manipulate data to produce results necessary for the solution of computational problems. These instructions perform arithmetic calculations and are responsible for the bulk of activity involved in processing data in a computer. The four basic arithmetic operations are addition, subtraction, multiplication, and division. From these four basic operations, it is possible to formulate other arithmetic functions and solve scientific problems by means of numerical analysis methods. So, arithmetic operations. Addition, subtraction, multiplication, division, increment, and decrement, like this. So these are the arithmetic operations. So we have to perform addition, subtraction, multiplication, division, or increment or decrement. Suppose I'm giving some instruction INC. So it will be incrementing of R1. So I'm going for the INC R2. If I'm going for the decrement, DEC A, that means A register value will be decrementing 1, decrementing plus 1, R1 plus R1 plus 1. Decrementing means DEC A minus 1. So addition means add AX comma BX. Sub AX comma BX means we are adding the two values or two registers. Subtraction means we are subtracting 2. Otherwise, I am taking as a mul AX comma BX. Div AX comma BX. So what we are going to multiplication or division, arithmetic, logical operations, and shift operations. So arithmetic operations means addition, subtraction, multiplication, division, increment, and decrement. These are the examples. So we are doing these arithmetic operations through the instructions. So in the arithmetic instructions in digital computers to manipulate data to produce results necessary for solution of computational problems. The instructions perform arithmetic calculations and are responsible for the bulk of activities involved in processing data in a computer. So the instructions perform arithmetic calculations going for the addition of two numbers. So it will be calculating the two registers. So we are adding two numbers. That is a arithmetic operation with calculations. So and these are responsible for bulk of activity involved in processing data in a computer. The four basic arithmetic operations are addition, subtraction, multiplication, division. So these are the major arithmetic operations are performing in a computer architecture, in a computer arithmetic. And these four basic operations, it is possible to formulate other arithmetic functions and solve scientific problems by means of numerical analysis methods. To representation of signed numbers, signed magnitude form, complement form. So how we are representing the signed numbers, signed magnitude and complement. In the complement, I'm taking ones complement and twos complement. So when I'm going for the ones signed magnitude means plus or minus values. Okay, something will be positive values or something will be negative values. Okay, we are discussing about signed values. Okay, if it is positive value, I'm taking as a 0. If it is negative value means I'm representing with 1. So one's complement means not gate. If I'm giving 1, output will be 0. If I'm 0, output will be 1. So complement means A equal to A bar equal to A. That is the one's complement. So suppose I'm giving 1 0, 1 0, 1 1, 1 0. Apply one's complement. So how can we apply ones complement? Means in place of 1 I'm taking 0 1 0 1 0 0 0 1. Okay, after the ones complement the resultant value, so it is a resultant value after ones complement. So 2's complement means after getting the ones complement I'm adding the 1 to the LSB, least significant bit I'm adding 1 to the LSB, that is a 2's complement. 1 plus 1 equal to 10, 0 plus 1 1 0 0 0 1 0. So it is a 2's complement value, 2's complement resultant value. So representation of signed numbers, that is a signed magnitude plus or minus representing with 0 or 1 in the magnitude, and it is a actual binary number, and complementing means one's complement and two's complement. So here the various arithmetic algorithms and procedure for implementing them with the digital hardware. We considering addition, subtraction, multiplication, and division for the following types of data: fixed point binary data in signed magnitude, fixed point binary data in the signed two's complement representation. So, any of the addition, subtraction, multiplication, division of the arithmetic operations, fixed point binary data in signed magnitude, fixed point binary data in the signed two's complement representation. So signed magnitude and signed two's complement representation, there are the two types are there in the arithmetic. So what is a signed fixed point data and fixed point signed two's complement we will discuss. And there are three ways of representing negative fixed point binary numbers: signed magnitude, signed one's complement, signed two's complement. So signed magnitude is a one type, signed one's complement is a two type, and signed two's is a three types. There are three ways to representing the negative fixed point binary. Most computers use the signed two's complement representation when performing arithmetic operations with integers. So, in the floating point operations, most computers use the signed magnitude representation for the Montesa. In this addition and subtraction algorithms for data representing the signed magnitude, and again for data representations are signed two's complement. So, most of the computers are using signed two's complement representation when performing arithmetic operations. So two's complement, what is the advantage means if I'm going for the subtraction. So subtraction means subtractor and subtrahend. It is about the subtractor and subtrahend. Subtractor and subtrahend. So if I'm going for the 1011, all ones are there. Which one is the largest value? It is the largest value. It is the smallest value. So maybe we'll get the negative value. So like these values, we can't do normal subtraction. Why? Because smallest value to largest value we are subtracting means it is difficult. So we will get the negative value. So how can we know negative value means? We are finding out with the signed bit. So in the negative value subtraction like this, we are using two's complement or one's complement to do the subtraction. So it is a better option to do the subtraction. So now in the most computers using two's complement representation, we are performing the arithmetic operations. And floating point operations, most computers use signed magnitude representation for the Montesa. So floating point means 1.01 like this. So I'm taking 1101.011. Okay, is it floating point? Yes, it is a floating point value. Why? Because after the it is some small values will be coming. So floating point means it is not the integer. Okay, floating means 0.00 something we will get. So like this also, it is better for floating point operations, also better for signed magnitude representation for the Montesa. And these are the fixed point binary numbers. And addition and subtraction algorithms for data representing in signed magnitude, and again the data representation is the signed 2's complement. So addition and subtraction with signed magnitude data is the familiar because it is used in everyday arithmetic calculations. So what are the arithmetic operations I am performing? I am representing with signed magnitude. It is a familiar to regular arithmetic operations. And the procedure for adding, subtracting two signed binary numbers with simple and straightforward. Okay, when I'm going for the adding and subtracting with the two signed binary numbers is easy in the straightforward. And deriving the hardware algorithm to designate the magnitude of the two numbers A and B. The signed numbers are adding and subtracting. We find at there 8 different conditions, and depending on the sign of the numbers and the operation is performed. So these conditions are in the following. First, the other column in the table on the showing actual operations to be performed with the magnitude of the numbers, and to preventing the negative zero, in other words the two equal numbers are subtracting with result of plus 0 or minus 0, that is with signed bit or signed magnitude. The algorithms for addition and subtraction are derived from the table and can be stated as follows. The words inside the parenthesis should be used for subtraction algorithm. Addition algorithm. When the signs of A and B are identical and the two magnitudes are attached in the sign of A of the result. When the signs of A and B are different, identical, compare the two magnitudes and subtract the smaller number from the larger. So when we are going for the subtraction, I am going for the is it A less than B condition or A greater than B condition. Previously we discussed subtractor and subtrahend. So if the result is if A less than B or the complement of A greater than B are equal to subtract B and B, make the sign of the result positive. The two algorithms are similar except from the sign comparison. The procedure to follow the identical sign in addition algorithm is the same as the different signs in the subtraction algorithm and vice versa. So what are the addition and subtraction in going for that one? We have to go for the ones and twos complement, and we have to check is it A less than B condition or A greater than B condition, and we have to compare A and B. Then we are going for the subtraction. Suppose I am going for the addition. 0 plus 0 equal to 0, 0 plus 1 equal to 1, 1 plus 0 equal to 1. Here 1 plus 1 equal to 0 and 1 is the carry. So 1 is a carry and it is a 0. So I'm going for the another. If I'm adding 0 plus 0 and 0 1, 0 plus 1 1, 0 plus 0 0, the resultant value will be 0 1. Otherwise I'm taking 1 0 1 and 0 1 0, 1 plus 0 1, 0 plus 1 1, 1 plus 0 1, triple 1. So I'm taking another value 1 0 1 0 double 1. So what is the 1 plus 1? 0 and the carry is there. Yes, 1 plus 1 equal to 10. That is a 0 and a carry and 1 is the carry. Here also 1 plus 1 equal to 0 and 1 is a carry. 0 plus 1 plus 1. How much? 10. Again 10. 1 is a carry. So 1 plus 0 plus 1. Again how much? So 1 is a carry and resulted 0. 1 0 0 0. Okay. It is the addition. So subtractor and it is a subtrahend. So subtrahend. So we are performing the ones complement for this one, and we can add these. So I'm going for the 1 0 1 0, and I'm doing ones complement for this one. 0 0 means 1 1, 1 1 means 0 0. I'm adding both 0 plus 0 0, 1 plus 0 1, and 0 plus 1 1, 1 plus 1 equal to 10. So it is a 1. I'm removing this one. 0, 110. So is it correct or not? We have to check. So what is the 1010 value? 2 power 0, 2 power 1, 2 square, 2 cube. That means 8 plus 0 plus 2 plus 0. 8 plus 2, 10. So 0, 0 means 2 power 0, 2 power 0, 2 power 1. That is a 2 plus 1 equal to 3. So 10 minus 3. Is it 7? Yes. So 2 power 0, 2 power 1, 2 square. 2 square means 4 plus, so like this, 0, 0, 1, 1. 2 cube, 8 plus 2, 10. And 0, 0, 1, 1. So 2 power 0, 2 power 1. I am taking this one as a 4 plus 2. So what will happen? I am getting 6. But actually what we have to get 7. So what we have to do? We can do 0 plus 0, 0, 1 plus 0, 1, 0 plus 1, 1, 1 plus 1, 10, and 1 is a carry. This one is adding here. So now what will happen? This one extra carry is adding to the LSB. 0 plus 1, 1, 1, 1, 0. Now what is the value? 2 power 0, 2 power 1, 2 power 0, 2 power 2 square. 2 square equal to 4 plus 2 plus 1. How much now? 7. Are we getting 7? Yes. So 10 minus 3 also 7. Here also 10 minus 3, 7. But here what I am applied? Here applied 1's complement for this one. Okay. So addition or subtraction algorithm, the sign of A and B are identical and the two are different. When the signs of A and B are different and identical, compare with the two magnitudes and subtract the smaller number from larger. So choose the sign of the result of the A less than B or A greater than B, and the two algorithms are similar except from the sign comparison. The procedure to be followed as an identical sign in the addition algorithm and the same as the further different signs in the subtraction algorithm. So here one example of addition and subtraction of signed magnitude numbers. Here I am taking operation plus A plus of plus B. So what is the add magnitude? So what is a plus A? Is it plus A? Plus A means plus or not? Yes, plus A plus B means plus of A plus B. Is it correct? Yes, it is correct. Plus A plus into minus minus. So A minus B. So A minus B means is A less than B? Yes, it is a A less than B condition. It is a minus A plus into plus plus minus A plus B. So minus A plus B means what will happen? Minus A plus B. What will happen? A, this condition. So is it belongs to which condition? We have to go plus A minus into plus 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 A minus B plus A minus B, and it is a minus A minus B minus of A plus B. Is it correct? Yes, minus A minus B. Okay, it is a add. Minus A plus B. Is it addition? No. Minus A plus B is not addition. Only A plus B. That means plus A and plus B are the addition values. Okay. So minus A plus B plus and minus A plus B. So these are the add magnitudes and remaining are the subtracting magnitude. In the subtraction, three conditions. Is it A less than B or A greater than B or A equal to B? So hardware implementation of these arithmetic operations. To implement the two arithmetic operations with the hardware, we have to store the numbers into two registers A and B, and A's and B's be the two flip-flops that hold the corresponding signs. The results are transferred to A and A's and A and A's algorithms for an accumulator. So hardware implementation, I'm taking two registers A and B registers, and to be using as a flip-flops means storing one bit of information. So here hardware implementation of signed magnitude addition and subtraction. I'm taking one here B register. So for this B register and complementing the B register means B bar, and parallelly adder means suppose A equal to 1011, B equal to 0000. Example. Okay, so what I have to do, I have to perform ones complement to this one. Okay, so B register and complement B, it was ones complement is completed. So after the completion of ones complement of this one, what we have to do, A plus B. So parallelly we are adding A and B. How much result, the resultant value will be stored in A register. Suppose I am taking sub AX comma BX. So what is the meaning? Subtracting of two registers and the final result will be storing in AX. So for the subtraction, what I need, I have to go for the ones complement of the subtraction. Okay, suppose AX or A equal to 1011, B equal to 0010. So I'm going for the A minus B. So what I have to do, first step, B is going to the ones complement. B is going to the ones complement. So what is the ones complement of B means B bar. So A plus B bar. A plus B bar. Why? Because the B is complemented. B is complemented means B bar. Okay. So 1011 plus B bar means what is the B value? It will be complemented. Means ones complemented. 0010 means 1101. 1010 Shall I add parallelly? Yes. So it is belongs to A and it is belongs to B bar. So here also diagram, B complement of B means B bar. So this B bar is parallelly added. So it is A and B bar. A and B bar. So A equal to 1010 and B equal to 1101. What I am doing here, parallelly I am adding both of this one. So parallelly adding means 0 plus 1, 1, 1 plus 0, 1, 0 plus 1, 1 and 1 plus 1, 0 and 1 is a carry. This carry is adding to here. So this carry adding here means here 0, 111. This one is adding here. Okay, 1 plus 1, 10. 1 plus 1, 10. 1 plus 1, 10. 0 plus 1, 1. So I'm getting the 0, 111. I'm adding this one. 0, 111 adding 1 plus 1, 0. 1 plus 1, 1 plus 1, 10. So I'm adding, after getting this one, I'm getting the 1000 value. The value is 100, 1000. So if I have to cross verify A minus B, are you getting proper values or not? So it is a flowchart of hardware implementation of signed magnitude in addition and subtraction. So hardware algorithm, the two signs of A and B are complemented by exclusive OR gate. If the output of the gate is 0, the signs are identical, and if we are adding the operation, the identical sign dictate the magnitude of the added up subtraction. The magnitudes are added with a micro operation of EA tends to A plus B. EA is the effective address. The resultant value will be stored in effective address. It is a flow chart of subtract operation and add operation, subtracting and adding operations. Okay, it is a subtract operation. When it is subtracting means after the ones complement, both are adding or not? Yes, both are adding. So A minus B. That means A plus B bar. Okay, after the complement of this one, both are will be added. Means for the subtraction, I need addition also. So complement with addition value, we are getting the output. So addition and subtraction with 2's complement. After performing the ones complement, we are adding LSB one value. That is a subtraction. That is a 2's complement. Okay, it is a BR register and it is a complement of parallel adder and it is a AC register. Okay, when adding to one to the ones complement, it is a hardware implementation. It is a subtracting and addition flowchart. Okay, these are the references. So discuss it today, computer arithmetic operations. So addition, subtraction, multiplication, division are the computer arithmetic operations. And here the representative of signed numbers means the plus value or minus value. The resultant is a positive value or negative value. We are defining with the signed bit, that is 0 or 1. So that is a signed magnitude. When we are going for the complement, one's complement, two's complement, these are performing for subtraction, mostly for subtraction. And fixed point binary data in signed magnitude, fixed binary data inside the 2's complement or the arithmetic operations are mostly dividing into two types, and integer floating point also in the computer architecture, and addition and subtraction with signed magnitudes. Okay, we are performing addition and subtraction with signed magnitude. Means suppose is it a less than b, or a greater than b, or a equal to b. So there are the three conditions are there to perform, and addition and subtraction algorithms are defining with three conditions. Okay, and it is a addition and subtraction with a less than b, a equal to b, and a greater than b. It is a addition and subtraction of signed magnitude a plus b minus of a plus b plus of a plus b minus of a plus b. So these are the add magnitudes. There are the subtract magnitudes are there, and it is a hardware implementation of flip flops, and it is a hardware implementation of signed magnitude addition and subtraction. It is a hardware algorithm for addition and subtraction, and it is a addition and subtraction with 2's complement. Means after the complement add 1, that is 2's complement. So it is a hardware implementation, and it is a hardware implementation of this one. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.